Hello everyone. So one more talk about spreadsheets. I think it's the last one. Yesterday, Hugo and Richard showed you about how to make a dashboard. Half an hour ago, François showed you all the new things that we did with spreadsheets. And what I would like to show you is what we did to improve performance in the new version of spreadsheet and dashboards, and also what we did to improve the performance in all versions of spreadsheet and dashboard. So during this talk, I'm going to talk about spreadsheet and dashboard, and for me it's the same product, so I'll choose one word or the other, but it always means both. So don't worry if I just say spreadsheet for the rest of the talk, it applies, everything applies for dashboard. My name is Vincent. I'm a developer in the team that creates spreadsheet, BI, and dashboard for Odoo. And it's going to be a talk in two parts. The first part, really short, what we did for this year. Second part, a bit longer, what can you do, what tools should you use to make your own dashboards and your own spreadsheets as fast as they can be. Before I start and dig into what we did, I need to tell you about performance and what it means to be efficient and performance. The spreadsheet runs on your browser, so that means that whatever we do, we are limited by your own machine. And the limitations, what we call the bottlenecks, they are most likely either in CPU, so how much things we compute, or with the RAM, so that is how much things is remembered, how much thing is in memory. And every time we find some improvements about performance, we need to play with this balance. Either compute a little bit more to store less if the bottleneck is in memory, or store a little more and compute less if the bottleneck is in CPU. And this is basically the balance that we try to keep in equilibrium so that there is no obvious bottleneck. And this is always the kind of change that we make when we make performance improvements. So what did we do? If I look at the analysis of the commits of spreadsheets, we did about 250 commits for features and 41 on top of that about performance. So that means that about 13% is commits about performance, and that also means that we have about one FTE that works in performance for the entire year. Most of the commits about performance, they are merged in version earlier than 18. So about half of them are merged in 17, and about half of that is merged in 16. So that means that you are already benefiting from a lot of the improvements. If I look at the loading times, absolute loading times, of course, your mileage might vary depending on what you have on your spreadsheet and on your dashboards. But with the cost of having a little more usage in memory, we managed to make the loading time quite a bit faster, about 1/4 faster. Of course, it depends a lot on what you have on your sheets, on your memory, but it's much, much faster. And then one of the things that we did that I think we should be really put a lot of emphasis on is everything about dependency management. So the dependency management are everything that says when I change something, all these needs to be recomputed. So if I change a cell, every cell that depends on them, and then every cell that depends on those, and every graph that depends on those cells needs to be recomputed. And this is one of the cases where we managed to reduce the CPU and reduce the memory at the same time by changing completely the algorithms and the data structure that we use by using our own custom data structure and not relying on the one standard in JavaScript and in browsers. So pretty much faster. I did a guesstimate for the numbers because depending on the use case that you use, it might be even much faster than that, almost like 2 times faster, and sometimes a little bit less, so around 80% faster is a good number. When we think about performance and when I treat the request about performance in my team and when we dispatch either this needs an improvement or is this a bug fix, I always try to keep some kind of range of numbers in memory. And my idea is that anything that is small, less than 10,000, anything on your dashboard, on your spreadsheets, needs to happen fast. One blink and it's done. When you get to one order of magnitude more, it should happen reasonably within 1 second. If you start playing with lists and with pivots and so on, it should happen within 1 second out of network time because we can't do anything about that. And then when you grow a little more and you add larger pivots and larger lists or larger computations, 3 times 1,000, so 300,000. It should work. And what I mean is it needs to work, but maybe it's going to take some time. Anything above that, you have to take care, use all the best practice that I'm going to tell you in a few minutes, and likely it's going to still work with at least up to 1 million, maybe more, depending on your machine. Now, second part, probably the most interesting bit, is what can you do about Spreadsheet? What can you do about your dashboard to make them fast, to make them snappy? And for all versions, I know it's a bit obvious, but it's still nice to remind people. For all versions, even before 18, you have to keep your spreadsheet as small as possible. And that might mean still very big because you need all the data, but anything you don't need, throw it away. So when you import lists and import pivots, they are formatted by default, so they look good, but if you just use that for reference, it's memory used for nothing. So clean the formatting. If you add a lot of trial and error to import your list and to import your pivot from Odoo or even your graphs, remove the data sources that are not used. And actually, you can see that they are not used because in the list of data sources, there's a small exclamation mark if they are not used. So if you don't need to keep them, throw them away, keep your spreadsheet small. There are also a few things that you can do in all versions to keep your spreadsheet fast. And the first one is a very common use case. You have a pivot and a list, or multiple lists, or multiple pivots and multiple lists, and you need to cross them. And this is the main use case of spreadsheet, crossing data from multiple data sources. And you do that using lookups. If you're a computer scientist, programmer, you know lookups is expensive. Lookups on sorted data is a little bit less expensive. Formula like VLOOKUPs, HLOOKUPs, and so on, they have a last parameter that is either true for my data is sorted or false for my data is not sorted. Do sort your data ahead of time. You sort them only once, and then every time you evaluate your sheets, you benefit from the performance gain of VLOOKUP true. So if you want the numbers, you go from O of n squared to O of n log n, which is much, much faster. Snapshotting. This is a hidden feature behind spreadsheet and dashboards. And what does that mean? Every time you make a change, any change you make to a spreadsheet, it's added on top of it through what we call a revision. So when you're building your sheets, you make a lot of tiny adjustments, you copy paste, you make formatting and so on, then you undo and redo and do them again, and it's perfectly normal. And there's an automatic system that will once in a while for you take a snapshot, so take all those revisions, write them only once in a file, throw them away. You still can get them and use them for history, but they are not processed anymore. So when you are in the design process and you see that the loading time of your spreadsheet starts to get a bit slow, it might be wise to go yourself in debug mode and go file and snapshot to force a snapshot right now. This will crunch all those revisions into one, and then when you reload only that one and not all the rest. It's much faster. Finally, small detail, but we actually managed to break a spreadsheet in our production like that. If you need to duplicate data that is on one sheet to another sheet, using copy-paste is a cell-level operation. So that means that the revision will take the tiny details of every cell individually and paste it wherever you want by describing all the details of the cell. It's much faster, very efficient to just duplicate the sheet and then delete what you don't need. It's literally the revision for duplicate is just duplicate with the ID of the sheet, while copy-pasting data from one sheet to another is all the detail about what you want to copy-paste. So, Odoo, before 18, keep them small, remove what you don't need, keep them fast, ensure your data is sorted, snapshot it, and duplicate if possible. But what about the new features? What about everything that François showed you? Well, I have two good news. First is that I won't explain to you again what's a dynamic pivot. And second, I will tell you that most of them are really good about performance. You don't have to take my word for it. I have actually a small test case that I want to show you about dynamic pivots. Do use dynamic pivots everywhere you can. There are use cases where it's better to not use them, and there are very, very little, and we did everything we could to remove those use cases. So dynamic pivots is much faster. So let me do a small performance demo about dynamic pivots. I'm going to kill my server and restart it so I'm clear cache, refresh my browser. So I start with nothing. I will start a timer, and then I'll go as fast as I can and open this spreadsheet, which is a fixed pivot with almost 1 million cells, so 850,000 cells. Let's do it. So start a timer, click on the thing, and then, yeah, let's see how long it takes for loading over, so almost 1 million cells. So obviously, you can imagine, you need to go to the server needs to send you back the file. 1 million formula, it's quite big, it's going to take some time. It's still doing it, don't worry, it's going to happen. Then, yeah, you got your formulas, but those formulas need to fetch data and then process it and put it in every cell. It's going to work, no worries. As I said, over 300,000, all my guarantees, it should work. So I'm not lying, there's data in some of those users, and there's data in the sums. So there we go, about 31 seconds. I'm going to do the exact same with dynamic pivot. So kill the server, restart it, refresh the page, so brand new, reset the timer. So once again, I'll hit start, click fast on the second spreadsheet, and it has only one cell that says, give me the pivot, with almost 1 million cells. So let's go fast. Yeah, it's loaded, of course, it's tiny. Oh, there we go, about 5. So I did this test a bunch of times. The largest difference I had was about this one. The smallest difference I had was about 3 times faster. So yeah, dynamic pivots are faster, and yeah, I can show you. Obviously, my data is there. It's computed perfectly, same as the other one. So yeah, in this case, I'm really happy because it's 6 times faster. It's a really good demo. Dynamic pivots are really good. Formatting is expensive. When you format using borders and backgrounds and formulas, or not formulas, but styles, we need to write on every cell what format is applied and then describe this format in details. Every time you make a tiny change in the format, we create a new kind of format that applies to all those cells. It's a lot of memory. It's not very memory efficient. However, data tables apply to a range and are automatically computed, so it's very efficient. So you can have all your data formatted as much as you want using data tables. I basically consider them no cost at all. So you can have 10 or 100 over a very large range. They cost nothing, in my opinion. It's not exactly true, of course, but it's almost nothing. You have seen the demo probably multiple times, computed measures. This is the most obvious way we can get rid of fixed pivots. You don't need to insert a column in the middle of it. Likely what you want is some computation based on the values of the pivot. Do use computed measures. They will save you also a bunch of space. So there's no gain in terms of CPU efficiency, but there's a bunch of gain in terms of memory efficiency. They are also very powerful. They are much more powerful than other very famous spreadsheet applications, which I won't name. You can go much further than what we have in those applications. Finally, array operations. This is probably the one that is the most difficult to understand because it's kind of programming your formula a bit different. So maybe I can show you. I have a spreadsheet that I use because it has a lot of dependencies from a lot of different things. What it means business-wise, it really doesn't matter because all we want to play is with playing formula. The only thing that matters is that I have 2,500 cells in here that contains computation, each of them slightly different, and I can verify they are correct because I have a diagonal of 0 that are green. What they mean, it's really not important, but there's one thing that is very interesting to see, is that if I look at the formula and I go down, they vary only by this last part, G13 to G12. And this is a perfect candidate to use array formula. By the way, there's 1,000 names for array formula. Some people call them vectorization, some people call them array computation. So let's copy this formula in a new row. I will modify it slightly, and what I want to do basically is I want to transform those 2,500 different formulas into one single formula that will give me the exact same result, except much more efficiently. So in this new column, I will modify this formula, and I would like it to spread over the columns. Over the rows. So I'm going to change it by saying, oh yeah, well that's reference, and now I'm giving you a range, and this goes to up till 61. I checked that beforehand. And as you can see, it is the exact same values everywhere. So this works, and now instead of having one formula per cell, I have only one for this column. And I'm going to get rid of this and redo it correctly in here. Maybe what I'm going to do is actually delete everything except this first formula. Let's do it correctly. Up. So we can see better. So I'll do the same. I want to go up to, I have a cheat sheet on top. G61, column G61 up. And it fills the entire column. But what I didn't show you is that there is another thing that varies if I go from one column to the other, and that is this H that becomes I and J and so on. So I can go further and use the array formula in 2 dimensions, and that's what I'm going to do. So 2BE11, I checked beforehand what was my last cell. And now I have recreated my entire 2-dimension array of formula. Each of them were different, they are still different, except they are represented in only one cell. So that also means that any operation that I make that should move this formula will need to be transformed only once. It is very efficient, I don't need less transformation. Obviously, memory-wise, it is, I gave it rid of 2 dimensions of data, so I go from n squared to 1, which is obviously very efficient. In terms of processing, evaluating, it's exactly the same because the values are the same, the computation are the same, so I didn't gain anything there. And I can check that it's correct because I have my diagonal of 0 that is formatted in green with conditional format. So I don't think it is wise to advise you to create your spreadsheet right away with array formulas, but I would say when you're close to done, when they're close to where you want to get them, it's time to transform all those VLOOKUPs and all those sums and so on into array formulas so that you can get rid of a lot of data, and then afterwards you snapshot, and then you're good to go. So this is array operations, array formula, vectorization if you want. Of this spreadsheet that I showed you with my cell and with all the dependencies, if I go through the optimization system that I showed you, so transforming all the formulas into 1D and then 2D vectorization, removing the styling and adding a data table instead, and then transforming the static pivot that is in this spreadsheet into a dynamic pivot, I get those numbers. In blue, you have the size. We went from 160K with the final optimization, which is less than 10K. In red, you have the loading time. Obviously, the loading time follows closely the size. And finally, in teal, green, I don't know, the third one, you have evaluation time. As you can see, it's a little bit better. It's not massively better because anything that was computed before still needs to be computed. But we have some gain because there's less memory use and less memory contention. So we gain there. All right, let's recap. I don't like to re-say what I just said, so I want you to tell me what I just said. I'm going to ask you one question. You have 2 choices. Please tell me the correct answer, and then we'll discuss it. So you have twice the data on the same sheet. What should you do? Duplicate or copy-paste? Tell me. Duplicate, copy-paste, duplicate. Obviously, you need to duplicate. Copy-paste is very inefficient in memory. Contiguous formula differ only by one cell. What should you use? Array operation or visualization? Yes, obviously, array operation. Virtualization is a word I invented. It doesn't exist in spreadsheet. Formatting, data table or custom formats? Yes, you got it. It's always the same direction. Data tables, this basically is 0 cost. Custom format is not a bad choice. You can still use it, and sometimes it is still useful. But prefer data tables everywhere. It's basically no cost. Pivots, dynamic or static? Yeah, dynamics. Dynamics everywhere. Until you can't use dynamic pivots, they are more efficient in every possible way, and also more customizable. I think I'm exactly right on time. So now it's time for questions. Thank you.
Well done.
Thanks.
This is going to be a very fast job because there's no question.
Ooh, nice.
Wait, it's coming. The only comment I have so far is very nice demo on the dynamic versus static spreadsheet
Thanks.
timings. All right, it's coming back. Is there any plan to consider and assist in correcting the changes in models between versions that affect spreadsheets?
So there are plans, but they are very, very complex. And the main problem that we have to tackle right now is that the spreadsheets mostly live in the file store, and when you migrate, we don't have the file store. So it's a work in progress. There are plans for it, yes.
All right. In V17, there was only 200,000 lines rows maximum in a tab. Is this limitation over now with V18?
I'm not sure that the limitation is removed, but I would say that if you need to go this low, this far down with this many rows, you're probably doing something wrong. So I'm not sure. I don't know.
Does conditional formatting benefit from the same performance improvements?
We did nothing for the performance of conditional formatting because it doesn't need anything. It's already very efficient. Basically, when you can make many conditional formats, they will not be evaluated until you see them for the first time. They are evaluated also when only the parts that are within the viewport or close to the viewport will be evaluated. And I've never seen any performance problems with the conditional formats.
About domains still, are there any best practices for the domains filtering data sources?
For doing what?
For the domains filtering data sources.
Best practice is filter as much as you can. So it comes back to the same principle, keep them small and keep them fast. So whatever you don't put inside your spreadsheet doesn't cost us anything. I think we have to stop.
I think this was for you. I'm not sure we still have some time more. About upgrade, will Spreadsheet be compatible when upgrading to a
So
version?
I think I already answered that question. It's going to come. For now, not yet, because we need the file store, but we have plans to make it working eventually.
I import 2,000 items in product app list, and it takes very long when I test button or import button. Oh, I'm not sure this is spreadsheet related.
It takes a really long time. I test button, import button, why? So this has nothing to do with spreadsheet, no. I don't know.
Started, so I had to go to the end.
Yeah.
Amazing job, BI team, you rock.
Thank you, yes, my team rocks, thanks. Thank you very much.
All right, that's it then. Thank you very much.